Good morning, everybody. Thanks so much to join us. I'm Domenico Fabio Masi, Marketing Manager EMEA, and today we are presenting Telit AppZone 4.0, our app-to-module development environment. I would like to introduce today's presenter. We have Martino Turcato, Cellular Product Manager, Fabio Pintus, AppZone and Cloud Specialist, and Giampiero Pilu, Application Engineering Manager. And I want to let you know that a recorded version of this webinar will be available. And if you have any question during the presentation, please type them into the question box in your control panel. We will have time for the question at the end of the webinar. So enjoy our webinar, and Martino, you can start.
Thank you, Fabio. Hello and good morning, everybody. My name is Martino, and as Fabio said, I'm a product manager with the cellular module team, and my main focus is on software and end-to-end solutions. So today I'm going to talk to you about AppZone, and I will try to show you how a no-module application development environment can help your customer build better solutions, decrease the time to market, and reduce the cost. What is AppZone? So in a nutshell, AppZone is an embedded development environment which allows to build and run code in the module, taking advantage of the integrated application processor. AppZone comes with an SDK, which includes the so-called IDE, the integrated development environment, the tool chain, and of course, the framework and the libraries that are used to compile and run the application. The documentation and the sample code are part of the SDK as well. So the SDK can support various environments and frameworks. For example, we still support Python for the legacy modules, but AppZone C is the most important environment and what we consider our flagship framework. It has been originally created in 2G and 3G modules. We have ported the framework to the 4G modules, and now it's going to be the reference environment also for new modules, which are based on CAT-M and narrowband IoT technologies. AppZone C is essentially a lightweight framework that has been designed for optimized performances and to be portable across various architectures, including those that are more constrained. The programming language is C and APIs are in C, of course. And the fact that it is a cross-platform framework enables the portability on different modules. And this happens regardless of the technology and the chipset that is being used in the module. So in this slide, you can see the traditional architecture of an IoT device. As you see, we have an external host processor that is connected to various sensors and peripherals. And the application is running on the external processors, basically. The module is connected through a serial connection or the USB port, and typically is controlled by the use of AT commands. In this second slide, you see how the architecture changes when you implement it with the AppZone. So all the peripherals are directly connected to the module. The application is running on the module, and you basically can get rid of the external processor, the associated memory, and all the glue logic. Now, before we dive into more details, I think it's good mentioning some of the key points relating to AppZone. So as you have seen, first of all, you have the possibility to consolidate and simplify the hardware and therefore reduce the cost of the device. Secondly, Having a framework that provides basic features and the enabling functions allows the customer to focus exclusively on the application. So the customer doesn't have to reinvent the wheel all the times and create some basic functions that has nothing to do with the core of the application. And so he can basically focus on the value-add software and the most innovative aspects of the application. As a consequence, the development cycles are simplified, they become faster, and this allows to reduce the time to market and the time to a mature solution. And as I said, this is independent on the platform. So as technology evolves or you decide to use a different module, you can still reuse the same application, the same code, because the framework allows to recompile the same application on different modules. Okay, just a few words on the framework and the more technical aspects. So AppZone framework is integrated in the module on top of the modern software and OS. So it is independent. And the framework provides the APIs that allows to control the modern functionalities, various hardware sources, peripherals, the OS function, of course, the TCP/IP stack, the file system, but also features like the hardware interrupts or the timers. The framework is a lightweight one, and this allows to fully take advantage of the hardware sources and optimize the performances. Multitasking is supported. The programming language is C, and usually the customer creates the application starting from skeleton code or modifying the sample code that is available in the SDK. We support both commercial and open source free compilers, specifically ARM or GCC. And for debugging, we support also JTAG, target debugging, and emulator. So the current official version of AppZone is the 4.02, which we have distributed earlier this year. And in this release, we have introduced some new features like the support for emulator, the support of static libraries. So this will simplify the management of more complex software projects. And various enhancements also to the UI, along with the new platforms that we keep adding as we come up with new modules in our portfolio. In the same release, we provide support also for Python for legacy modules, and there is also a section on Linux for Linux NC1, but this is protected by password. This is going to change in the future, so I will spend a few words later on this. So regarding the IDE, AppZone IDE is based on Eclipse. In this case, we have developed a number of plugins to deliver a better user experience, and we are providing functions like an enhanced project creation wizard. A DAT command console is integrated in the interface. We can manage the file system in the module and deploy the application and configure the application. And we also have debug tools and the toolchain integrated in the same environment, of course. The emulator is another important part of the SDK, and the emulator allows you to test the application on the PC without necessarily having the hardware, the actual hardware and the module. In this case, you need from Eclipse to switch to debug mode. We will see an example later. And then you can launch and monitor the state of the app as it evolves in different states. So you can set the breakpoints, you can step through the code, you can check the value of variables, and so you can basically monitor how the code is evolving. This tool allows also to emulate some of the hardware features available in the module. For example, you can simulate GPIOs and set the value of the GPIOs to trigger the specific behavior in your application. You can trigger or monitor events, so you can simulate some network events. You can monitor the output of the serial ports, simulate TCP/IP communication and SMS sending, and some other features. So in this table, you can see the list of the module series that we support. This is ranging from 2G, where we support exclusively on the G910 code AppZone. We have all the 3G series, Cat1 and Cat4 modules, and as you see in the bottom, we have also the new Cat-M and narrowband IoT Qualcomm-based ME910C1 and ML865. On the right-hand side, you see the memory available for the customer and the customer application. So typically, we have 5 megabytes for the file system, where you can store first of all the application, but also other files that might be configuration files or other data, and 2 megabytes of RAM. So to quickly summarize, here's a list of the main takeaways that we just discussed regarding AppZone. First of all, it is an embedded framework specifically designed for cellular modules. It has been designed to privilege real-time performances and be lightweight and resource efficient. It has been designed to simplify the integration of third-party libraries, protocol stacks, and peripherals. So basically, you have access to most of the low-level features available in the module. It's available across all cellular technologies and form factors, as you have seen. And this includes also the new modules for Cat-M and narrowband IoT technologies. And this was possible because it was easy to scale down the framework to accommodate the new architectures, which are more constrained. But still, AppZone, having a small footprint, can fit these new requirements. Another important takeaway is that AppZone is not only an environment to write applications, but it's more appropriate, I think, to consider AppZone kind of toolbox to effectively use and expand module capabilities. So beside apps, we can, for example, expand AT command set. We can develop drivers for external sensors and peripherals. And we can also simplify the user experience in terms of usage of cloud services, leveraging the Telit agents that we provide in our software architecture. And you will see in the coming months new announcements on how we're trying more in general to enhance the edge logic capabilities, and AppZone is a centerpiece in this strategy. So when we talk about lightweight end-to-end, for instance, or cloud access, AppZone will have a relevant role in these aspects. Just a few examples on what can be done with AppZone based on the use cases that we have seen coming from some of our customers. First of all, let me spend just a few words on this slide. As you see here, I was mentioning that AppZone is not only for app development. As you see in these slides, we have a mixed architecture. So in this case, we still have an hosted architecture where the external microprocessor is part of the design, but we are using AppZone in order to expand the AT command set and expose those functionalities that might not be available in the standard command set. This is another use case. This is a customer that has developed a meter gateway and is using AppZone. This is not only a meter, but also a communication hub for smart metering. So basically, along with the meter and other external peripherals, you see the customer connected to the module a Zigbee front end, and AppZone was essential in making possible to support this the performance and the requirements that were associated to this specific architecture. So, what were the key points for decision for this customer? First of all, the cost. Then the real-time performances, because this was required by the fact that he needed to directly connect to a Zigbee front end and handle all the traffic that was sent and received by this front end. The reliability of AppZone. So AppZone is simple, and making it simple make it more reliable and stable. The access to low-level resources, as I said, and also the flexibility and expandability. So keeping it simple allows to keep it also very flexible and expandable. This is another use case. This is a tracking system. And also in this case, the customer decided to go for AppZone because he could reduce the cost, of course, of the overall design. The pre-integration with the GNSS was also appreciated, and the fact that the application could be developed in a single environment without having to put together different pieces which were disjointed or, let's say, based on different environments. And this is, we were talking about the possibility to expand and change the AT command set. This is an example of a smart home gateway. In this case, the customer was looking for a solution that allowed to migrate the application, the existing application, from a pre-existing module to a Telit module. And the migration was simplified due to the fact that the customer didn't have to change the application, the external microprocessor, but just to adapt the interfaces on the module and implement the missing AT commands or adapt the interface of the existing commands. So what's next? There is a new release of AppZone SDK that we are testing, and we are almost ready to launch in next quarter. This should happen end of next month. And this release will introduce the official support of the ME910 C1 and the ML865 C1 modules. We are also going to release with these new modules an updated version of the AppZone C frameworks, introducing POSIX compliance, for instance, and other new features. But we will still guarantee the compatibility with the past. So if there are customers with applications already developed in older modules, they will be able to port the same code in the new modules. But for this new platform, we will deprecate the old APIs and we'll invite the customer to use the new ones because they are simply better and newer. A beta is already available, so please get in touch with the technical support team in Europe that is in charge of support for AppZone. So, and if you want to test the SDK, they can provide offline a beta version of the SDK and also a beta version of the software module, so that the two are aligned and you can get the latest features. One last thing about the support of Linux for Elina Intensive 1. Currently, as I said, this is not open to everybody. You need a password because we were supporting this only on a project basis with a limited number of customers. But in the next version, we will open it up and will allow the usage by all customers. We will also provide clearer guidelines and documentation on capabilities and what can be done or not. So, for instance, there will be some rules and limitations, like it will not be possible, for instance, to modify the kernel. But let's say that for now, on the Elina Intensive 1, the hostless applications will be based exclusively on Linux, but we are also planning to extend in Q2 next year the support of AppZone C to Elina Intensive 1. And so we will basically cover the full range of low-cut modules, and AppZone C will be the reference environment for all these modules. One last note on tools and documentation. Here are your references to get all the information for relating to AppZone. So you can go to the developer page to find all the documentation, the installer, and the user guides, and you can also contact the technical support in Europe and America if you have specific questions or you need support for your software development. So with that, I'm done, and I'm handing over to Fabio that will provide some examples, and we show you how the SDK works. Thank you.
Good morning, everyone. I'm Fabio Pintos, and as Martino said, I will show you a few additional information about the AppZone development environment and how to use it to create applications. First of all, I will show you just quickly what is the flow to create a new application. So the first step is just create the new project on the SDK. As Martino said, we use Eclipse as the base IDE. So just create a new project using the Eclipse IDE. Then the application will be written starting from the skeleton provided by the SDK, or using an example application as a starting point. Once the first core of the application is done, you can compile it using one of the available toolchains, so ARM or GCC, and then load the binary file, the binary application on the module or using the emulator. Then you can execute and check the application flow and see if everything works, or debug the eventually if there are problems on the application itself. So this is the main aspect, the main phase of the SDK. You have the projects and the code on the center of the screen. As Martino introduced, we have an improved project creation with a wizard that allows you to create a project for each module. So you can select which product you want to deploy the application to, which firmware version. So you can select also what is the software version of the module when the application will run. And as you can see, you can, from the wizard itself, select one of the sample applications as a starting point. But going ahead, I will show you quickly a few of the advanced functionalities of the SDK. So, for example, we have the IT command console to communicate with the module and send AT commands or deploy the application itself. The buttons to actually deploy and start the application and configure the application itself. How to interface with the module file system and manage the files on it. And we also have the possibility to interface with systems of software versioning like Git. And lastly, the possibility to use debug tools directly from the SDK. So you can interface with the JTAG target tools directly starting from the SDK itself. All the documentation available from for the new SDK format is available in Doxygen format. And you have a detailed file and information for each other file of the APIs. For example, regarding file system functionalities, we have two possible formats of implementation. We have the POSIX implementation with all the APIs to access and read, open files, create directories, and so on. And the same implementation also in the SDIO flavor. So you can select, depending on the type of the application you want to build, or if you want to port an existing library which already has one of the two flavors, you can select one of them. About peripherals and system, we have several API groups to interface with the module. For example, you can get information with this M2MB info header file. So get information about the module itself, as such serial number, the firmware version running on the module name, and so on. Also, we have GPIO functionalities. So we can manage all the GPIOs on the available GPIOs on the module. So we can open a GPIO using as you can see, everything is handled as a file handle. So we are using standard approach as in POSIX logic, and every GPIO can be opened, configured in the output or input mode, and the value can be read or write to the required value. Also, we have the possibility to control the state of the module, so we can reboot it and shut down the module itself directly from the SDK, from the APIs. Also, we have the possibility to interface both with I2C and SPI devices as a master. So we are the master of the bus in both I2C and SPI implementation. And there is the possibility to open the bus and read and write data on it for both the the bus of SQL C and SPI. The same applies for UART and USB interfaces. So we have, in this case, we have the same logic for the APIs. So we can open and close the file descriptor for the UART, the main UART and the auxiliary UART of the module, and also the available USB channels, and then write and read in data to and from them. This can be used both for logging functionalities or for point of communication from between the module and an external environment, whatever it is. Then we have the possibility to manage the timing of the module, meaning the possibility to use the RTC functionalities of it, for example, to create an alarm or manage the clock of the module itself. So, for example, get and set the system time, or also the possibility to create and use hardware timers. So the possibility to schedule events to run a single shot or with a periodic running mode. Also the possibility to set the timers themselves in an auto start way. Moreover, we have the possibility to manage all the network and communication functionalities. So, for example, manage the cellular networking itself. So, get the cellular registration info of the signal strength information. Also, we have the possibility to manage the SMS functionalities directly from the APIs, so send and receive SMS from the code of the application. This can be used, for example, as an input from the outside. And most importantly, the possibility to manage the PDP context configuration and activation to have an internet connectivity for the application itself. So the possibility to create and activate the internet connectivity, and get obviously the information about the connectivity itself, like an IP address we are using on a block flow on how to create the application and run it. So, yellow word application. The first thing for this demo application is to create the log configuration structure, which will be used to define which is the output port and the logging mask. Then once we have defined that we want to use the main UART port, we will init all the configuration structure and start to send messages in a loop. This can be done, I will show you immediately this way. So basically, let me just quickly overview all the SDK in live. As I said, we have the AZ console, the C console to communicate with the module, the possibility to see the building output from the console tab, and from file we can create all the projects and libraries using the Telit enhanced wizard. So, for example, Telit project, I can select here the family I want to use for the project, provide a name for the application itself, and then select which toolchain I want to use. So the free and open source GCC or the commercial ARM compiler. And then for the specific toolchain, select which firmware version we want to use on the module. Actually, even if the SDK provides by default a subset of all the, let's say, the official released firmwares, there is the possibility to install plus the possibility to have additional betas to have new functionalities that are not available yet on the official release. So let's go to the Hello World application. The main point is as you can see, we have the skeleton of the application with the header files and the source files, and the starting point is in the main C file, which, as you can see, it's all here. So we have as I said, we have the login configuration structure that is set to use the main UART, and with a specific debug mask, so we can also select specific levels of debugging. Then the login configuration is initialized, and from this line, it is possible to actually print the data on the main UART. Then, as you can see, using this make macros, we are sending data on the UART, and there is the logging loop that we send every 2 seconds a login message on the main UART. Now I will build this application using this button to build the AZ project. Okay. And now I have the application built, and I can connect with the module. No, sorry, I have to actually start the module. Here I can select the communication port here and connecting to the USB interface of the module, connecting to the module. As you can see, I'm connected, and now I will simply drag and drop the file here. Now the file is actually being deployed on the module file system, and I will start it in a few seconds. Here, this is the button to launch the application on target. So now the application will start. I have the UART here already connected to the module. Here you will see the output of the application itself. As you can see, I have the first login information, and then the loop printing every 2 seconds. This is the simplest application that we can create, actually, and just showing how to interface with the UART interface. Now we'll go back to the presentation, just a second. Okay. And okay, let's go again ahead. Another example I want to show you is the MQTT SSL demo application, which initializes the log system as in the Hello World demo, then creates a task to manage all the MQTT client code, and enables all the PDP and network management to connect to the internet. Then we'll start the MQTT client, in async mode, and configuring all the parameters to connect to the MQTT broker, and also the SSL parameters. Then once the parameters are configured, they will pass to the MQTT client, which will be then connected to the broker itself. From this point, we will start a publishing loop that will send log messages to our cloud, to the IoT portal from Telit, and get the reply on the reply topic. Okay, so let me switch back to the other monitor. Okay. Here, as you can see, this is the other application code, which is a bit more complex than the Hello World, actually. The starting point is always the same. So we have the main function, which will define all the logging functionalities, and then we'll create a new task here to manage the MQTT client, providing the stack information about the new task, the priority of it, and the message box size, and then the entry point for the task itself that I will show you immediately. So basically, once the MQTT main task starts, the first thing that does is to initialize the network and the PDP functionalities. So we'll check for the registration, starting the initializing the callback that will be called when the registration event actually happens. Once it opens, we have the semaphore here that is unlocked, and then the code will go ahead and initialize the PDP context, setting the APN and the user and password for the PDP context itself, and then activate it from using this API. Once this API is done, another callback will be called to notify the application that the PDP context is actually running and ready to be used. So once the callback is done, this semaphore is unlocked, and the actual MQTT client can start running. So I will go into this function. So as I said, the first thing we need to do is to initialize the MQTT client and the network used by the MQTT client. Actually, this is an open source library that we port. So Lightweight MQTT, which is based on BSD sockets and Unix threads, and we ported it in no time, because the APIs are designed to be compliant with standards, so it is easy to port existing libraries. Once we have initialized the network, we can configure everything. So the network callbacks to read and send data on the network itself. So to manage basically the socket, which will be used by the MQTT client, and the timers to be used to check the keep alive for the MQTT, so to keep the connection alive, and to send data each time the timer expires. So as you can see here, we are setting a timer in order to send a message every 10 seconds. So we are publishing a log message every 10 seconds. Then once we have initialized everything, we can define the options to connect with the server. So we are defining the client ID, the username, and the password to use to connect to the MQTT broker. And then we are configuring the SSL parameters. So we are defining TLS 1.2 and the cipher suites that we want to use to connect to the server. And then we will pass this structure, which has all the configuration for SSL. Let me scroll down directly to the MQTT client. So we are configuring the SSL section for session for the MQTT client here. And at this point, we are ready to actually connect to the server, which is done using this API, which connects the socket to the server, and then we are going to connect actually to perform the connection to the MQTT broker. So we are sending our credentials to connect to the server. Okay, once the server is connected to the client, we are ready to create another task in order to manage the asynchronous sending and managing of the MQTT client. So we will have the loop here that will be sent here every 10 seconds. As I said at the beginning, every 10 seconds we'll check for the timer and send this string on the server with an increasing counter. So I will prepare the publishing message and send it to the to the server using the MQTT publish API here. This is a loop we will send every 10 seconds. So let me show you the code here. And here I will drag and drop the application to the module again. And once the dragging is completed, I will start it, and we show you both the module output and the server output itself. Let me get again the interface here, and also here the portal. Okay, as you can see, we are activating everything. The code is running, and let me scroll. Oh, sorry. Okay, as you can see, timer timeout, time to publish message. So we are sending the message on the cloud, and we are receiving on the related topic the reply success true. And every 10 seconds we are sending this command. And as you can see, now the module is connected here 9 seconds ago. And if I go to events, we have the let me refresh the page. Okay, as you can see here, count 3, and the module is still going, and each 10 seconds a new publish is going to output. That's it. Okay, so I think I completed my demonstration. If Fabio wants to take over and go ahead, any questions from?
Yes, thank you, Fabio. We received some questions. The first one is, why do you think AppZone is important in Telit portfolio? Do you think that hostless architecture will become more relevant in the future?
Okay, I can take this one. I think that AppZone has always been an important piece in our portfolio. So Telit has been one of the first module vendors that has been investing and launching an integrated application environment to create a module application. And because we believed that this was a key factor to simplify the implementation, to optimize the overall cost of the solution, to simplify the design, and basically speed up the time to market for the customer. And we still think the same, of course. And actually, we are increasing our focus on this. And since going forward, we see a trend as most of new chips, especially the low-cut, CAT-M and narrowband IoT, they are coming with an integrated app processor, specifically to support new use cases and hostless use case. So we think this is something we need to we will support in the future, and as I said, we will be increasing our focus because we think this will become more and more important for new applications.
Okay, we have another one. What is the process that customer should follow if she want to implement an application in Telit AppZone? How can you support?
Okay, this is for me. Well, as already both Martino and me introduced, the first thing to do is to go to the to the website and check for the online documentation, and again we can provide support as a technical support and development to give a kickstart for the application and provide help if they are having issues with any API usage, and also to understand maybe if their application has some issues in the developing. Again, we are here to help them. So first thing, just contact the technical support for EMA.
Okay, good. We have another one. What is the architecture of the integrated app processor?
There is not one single architecture. I think we should make this clear, because let's say that all the modules have a different, might come with a different processor, and that's why AppZone has been designed, and we did it on purpose to provide an abstraction of the underlying architectures and also the operating system, because this is how we can create this separation between the architectures, the underlying architectures that might change, and the application.
Okay.
So AppZone has been designed because in principle it should not affect the design of your application. So even though there are differences and between different cores and different clock speed, and this can be seen from the application, but let's say from the design can be maintained the same. Then relating to the specific architectures on the older chipsets, we have ARM11 cores, which are shared with the modem. Sorry. In the newer modules like the Mi910, we have Cortex-A-based architectures with a higher clock rate. And but going forward, what we see is that the Cortex-M architectures will be more popular, especially for low power applications.
Okay. We have the last one. What are real-time performance I can expect?
Well, in general, we are able to react to events with 1 millisecond of duration. I mean, so even in our applications themselves, we are using the GPIO interrupts with 1 millisecond timing, and communicating with external devices with this real time. I think 1 millisecond can be considered real time in an embedded environment.
Okay. Good. For the L910 one, the actual support for AppZone Linux. If you
As I said, on the L910 one, we currently, since AppZone SDK is the SDK, reference SDK for all of our platforms, and is the unique environment that we provide for all of our products. We are also providing support for Linux. Currently, it is password protected, because we used to provide support only on a project basis, as I said. Now we think we can come up with a more straightforward support model, and so in the next release it will be open to all customers, and we will provide more documentation and guidelines on what can be done and cannot be done, and what are more in general the capabilities of the system. So stay tuned. In the coming weeks, you will see the announcement once we publish the version 4.1 of the SDK.
Okay, we have another one. So we need the commercial approval of the project to access Linux support.
This is correct for now. It is going to change as I said, with the new release of the SDK.
Okay, I think that that's it. We don't have any other questions. Okay, so thank you everyone. It was a pleasure being with you today. If you want, next week we'll host another webinar based on Telit SynWise on Wednesday, 26 at 10 as usual.